Okay, so hello everyone. So we will look into the XCP calibration tool. So this XCP calibration tool is developed by Activia Technologies. It is a professional tool, uh, desktop software tool built for automotive and embedded system engineers. So it provides a complete workflow for communicating with ECUs, monitoring live sensor and signal in real time, and writing, calibrating values directly to the ECU memory. So this is the interface of the tool. So firstly, we have to select the hardware interface. So this tool basically supports for two hardware devices, which is the in-house device, which is Activia USB to COM. So if and another one is PCAN. So I will show you a demo with our Activia USB to COM device. So my system is directly connected with the ECU. So after the hardware interface, we have to select the transport mode, which is CAN and CAN FD. So this our device supports for both CAN and CAN FD. So after this, you have to select the bird rate of the device, and after that, you have to select the COM. So right now, my COM port is 12. So after this, I will just say start interface. Okay, so the interface has started. The handshake has been performed. You can see at the top right corner, there is a button, there's a status button, status bar, which is connected. If you just disconnect, so the interface stopped. So you can see it got disconnected. Again, if you click on connect, so the handshake performed, and you can see the status. So this is the first communication page interface. So at bottom you can see communication log, where this log is basically to monitor the slave and master responses, where you will have timestamp and an identifier, which is basically the ID, TX and RX ID, the direction, the data length, and the actual data. So these buttons are basically, this is for expand and collapse, even for better weaving, and this is for pause. If you just pause the log, this logs get will pause, and the top is to jump to the first entry. Basically, well, if you start calibrating or measuring, you'll get so many values, so many responses flooded. So if you want to watch, just jump to first entry, you can jump even it goes to end. You just clear the log. If you want to clear everything, just clear, it will be clear. And if you click on save, the log will get saved as xcp log.txt in your system. So yeah, this is basically the log communication log. And at the top right, you can see the help button, where if you click, you can see a user manual button you can download, and we have generated on the user manual. So in that we have mentioned so many steps. You can follow those, and you can watch a YouTube video also. Okay, so after this, I will show you. We'll move to calibration. So here is basically where if you see at the right side, you can see devices. Here if you click on double click on the devices, you will show up a box button, where you have to enter the ECU name, whatever name you want to give to your ECU. There are some default names, but I'll go with ECU1. Okay, so I'll just add it. So after you add, a device tree appears, where you will see all these parameters: database, protocol, measurement list, calibration graph. So initially it is empty, it doesn't have anything. So first step is you have to enter the TX ID. So, and you have to enter the RX ID, master and slave ID. So in my case, the TX ID is 300, the slave ID is 301. After this, we have to load the A12 load the DLL file. So I will load the DLL file from my system. So the DLL has been loaded. After that, I can just say connect. So yes, after the connection, you can see it connected successfully. If you want to ensure whether it got connected successfully, you can see this uh, EAF1 response. Basically, it says ECU unlocked successfully. This EAF1 response is basically a positive response from the ECU. So if there is an EAF1 response, you can proceed. The ECU is unlocked. If you disconnect, you'll see EFEF. This FF is sent by me, and the FE is sent by the FE is sent by me actually, and FF is positive response is sent by the slave. Okay, so I'll connect again. If you want to connect again, you have to load the DLL once again. So I will just say connect. So whenever you want to disconnect and connect, you have to load the DLL every time. And so after this, your ECU is unlocked, and you can measure the value, write the values from the ECU. So for that, we have to go to database, and here we have to click on this folder icon, double click, and if you double click, you will get an folder. You can select a file from the folders. So I'll select an A12 file. So the A12 file is loaded. So here you'll get variable name, address, and type of the address. So you can, if you want to select, you can select, or you can search or filter your variable by address or type or name. So I'll just filter it by noise signal. Okay. So if you right click on this any variable, you will get an option where you can add that this variable to measurement list, or you can add it to calibration. So firstly, we will see uh, add to measurement list. So I'll add this noise signal to measurement list. So immediately when you click on add to measurement list, it immediately reflects you to measurement list, this tree. So in right side, you can see there is the variable is added. So in this, we have three things where you will be able to set the rate of the pooling mode, pooling or DAC. So it supports two modes, pooling and DAC. Pooling is basically master sends requests continuously, and ECU responds to that request continuously. So DAC is basically we set an initial setup state for the ECU, and ECU floods, sends data asynchronously at a particular rate. So this active state is basically to, if you add a multiple variables in the measurement list, you can just uncheck this, and uh, uh, you can active other variables, and you can see what is happening, and you can start the start for measurement. Okay, I'll just clear the log. Okay, I'll have set this variable in back mode. So I'll just start logging, start measuring. So you can see the logs are appearing. You can watch at the graph. The graph is being updated live. We'll just stop this. Okay. And now you can see the graph this is the graph which is sent by this noise signal, appeared by noise signal. So the uh, data is varying very much. So you can, if you want, you can see the logs also. And another feature is you can zoom in at a particular uh, timestamp. For example, if I want between 6 seconds, so I will just zoom in and see what is happening between this particular timestamp. So yeah, this is one feature. And if you want, you can add multiple variables. Uh, I'll just add variable from here. Okay. So I'll set this in pooling and clear this. I'll set this in pooling and I'll give start. So if you can watch the graph, you can see both the variable graph has appeared. So I'll click stop. And now you can watch what is happening with both the variables. So at the right side, you can see you have two buttons here. The basically the variables loaded from the measurement list reflects in the graph. So you can watch a single variable, what is a single variable graph. For example, if I want to watch bit slice one, and I'll uncheck this, I'll you can see this particular variables graph. And if I want to see only noise signal, I can see only this uh, graphs, this variables data. Okay, if you want all, you can select all and see watch what is happening with all the variables. And parallelly, you can also look into the logs for better understanding. Okay, after this, so this is a measurement to measure the values from the RAM. So another one is feature is to write calibration, which is basically write some value to uh, the ECU address, ECU RAM. So I will add the same address, noise signal. Okay, I will add this. If you right click on this variable, if you actually click on add to calibration, so this variable gets added to calibration, and here you can just enter at, the value, what value you want to add. So I'll clear the log. Okay, and I'll just add a value 10. Okay, so I'll give it right. So you can see the log, the value. This is the initial. You can see first here written successfully. If it does not write, it will pop an error. Okay, so basically it will. This is the command flow where you set the set meta. This actually is basically set meta, and then you pass the address in little endian, and then it gives a response, positive response, and then this F0 is basically a download where you write the data to the uh, yeah, particular address. So the 0A, so the 01 is the length. What is the length of the data? So this 0A is basically in hexadecimal of this 10, and it has given a positive response. So F5 is basically upload this. So you can see a positive response has been uploaded. So yes, this is the tool. This also supports for multiple ECUs. If you just double click on devices and add ECU2, ECU given the same name, you can just add ECU2. Okay, it adds another device tree. Here also same, you can just come and enter the TX and RX ID and load the DLL connect, and you can load the database file. And same thing you can do with multiple issues, not just one, multiple issues. So yes, after everything, if you want, you can after everything is done, you can just disconnect the application interface. So this FEFF command follows. You just disconnect. So hardware interface disconnected appears. Okay. So yes, this is the XCP calibration tool powered by Activia. Thank you.